All right, guys, here we go. Objective 5.3, graph polar equations. However, we are doing part 2 or part B, whatever I label there, part B or part 2, whatever you want to call it. Now we're going to do the cardioids graphs, okay? The cardioids and the limacons graph. Now, just like the word cardio, okay, has the meaning of a heart, the cardioid graph is labeled like that because it was named like that because the shape is similar to a heart, okay? So the cardioid graph will always look like that. The limacons look similar, but it has an extra loop. So let's first understand the cardioid first, okay? Cool. Let's talk about the sine cardioid curve, and then we'll talk about the cosine cardioid curve. So here's the equation for a sine cardioid curve. R equals a value of A plus the B value times the sine of theta. The A equals the B value. So where the A equals the absolute value of B. In other words, this value of A will be the same as this value of B. For example, if this is a 2, this will also be a 2. If this is a 3, this will also be a 3. Okay? So that's what makes it a cardioid if these two values are exactly the same. Even if there's a negative as part of the equation, R equals A minus B sine of theta, A and B will be the same exact value. That's why we say the absolute value of B right here. Okay? So that's what makes it a cardioid. Now, where do we graph it? Well, if it is a positive sign, we want to make the heart shape, the cardio, be on the positive sine pole. So we start from the origin. Right now we're not going to shift. There's no translation, so our H and K will be 0, 0. So I'll start from 0, 0. I'm going to go up. Look at the arrow going up the value of A, going to the right, going to the right, the value of A, and then I will go ahead and shape my cardioid coming back this way. Okay, so it starts here 0, 0. We go positive direction up to the sine pole and back here. Okay, so this value of A to the right and to the left, and the distance on the sine pole will be the absolute value of B plus A. So you're adding these two values to make it the longer length. We call this the shorter length and the longer length. Okay. If I'm dealing with the negative sign, I'm going to go to the negative direction of the sine pole. So imagine that this is a y-axis, x-axis. The negative y is down here, so I'm looking for the negative sine pole, which is down here. Okay? So I'm going to go to the right to start the heart shape, the cardioid. So 0, 0, go up to the right A, and then form the cardioid and back to the center. Okay. Notice that we go to the right and to the left, the value of A, and we go down the value of A plus B. Okay. Now the cosine is the same thing, but we just have to focus. If I have a positive cosine, I'm going to go over here to the positive cosine pole. If I have a negative cosine, I'm going to go to the negative cosine pole. Okay? So we still go the value of A, and then form the cardioid with A plus B, and then come back, connect the value of A, and finish exactly where you start at the origin or the H and K starting point. Okay? This one would be a positive cosine, and it would end right here at the starting point. So that's what a cardioid looks like. As long as you do A for the top part or the bottom part, and then B, A plus B for the longer part of the cardioid. Okay, let's do one where there's not so messy. Here's an example, okay, 2 examples with numbers. Okay, so if I have 2 plus 2 sine of theta, H and K, our starting point is 0, 0. Notice that I'm going to go to I know it's a positive sign. So if I have the x-axis and the y-axis, this is my positive sign. Okay, that's where the positive sign values are, is up here. So we're going to go 2 to the right, 2 plus 2 makes 4. We go 4 up, and then come back touch the -2, and finish your cardioid. Okay, so there's a, with numbers 2 and 2, positive sign. Here's a 2 plus 2 positive cosine. So I go up 2, go far to a 4, and then back 2 here, and that's a positive cosine. Okay? All right, let's go ahead and do one from beginning to end. Here we go. The equation is r equals 3 plus cosine, 3 plus 3 cosine theta. So our starting point is 0, 0. Okay, our h and k is 0, 0. So that's my very first point. I have a positive cosine. Here on quadrant 1 and 4 is where my positive cosines are. So I'm drawing my cardioid here on the positive cosine pole. I'm going to go up 3. So let me use a darker marker here, Sharpie, to make my points. I'm going to go up 3. 1, 2, 3. That's my point right there. I'm going to go down 3. 1, 2, 3. Then I'm going to go the distance of 3 plus 3 to make the longer part of the cardioid, which is 6. 1, 2, 3, 4, 5, 6. It puts me outside of here, but I know that this is 6. Okay, now I'm ready to draw my cardioid. I'm going to go up 3, go all the way to the 6, back to the -3, and finish the cardioid shape. Okay, it looks kind of funky, of course. Can make it nicer. There we go. And there's the cardioid. Very simple, right? Our value of A is 3, our value of B is 3, the value of A is 3, the absolute value of B is also 3. That's why we went 3 plus 3, 3 up, 3 down, and 3 plus 3 made 6. Now let's go ahead and the things I'm going to ask you are, what are the x-intercepts? Well, on a cardioid, we only have 2, okay? I have 0, 0. That's where we started on the x-axis, and I have my 6, 0. Those are my x-intercepts. For my y-intercept, I have 3. I have the origin, which is 0, 0. Yes, it is the x-intercept, but it's also the y-intercept. Then I have 0, -3, and 0, +3 up here and down here. So there's 3 places where it touches the y-axis, or we call it the sine pole. Okay? Very simple, right? That's the cardioid. So let's do a negative sine cardioid. 2 and 2 are the same, so I know it's a cardioid because they're the same. The value of A is 2. The absolute value of B is also 2. Okay, if you take the absolute value of this value right here, -2. Because it's a negative sign, I'm going to be down here. Let me make a big deal about it. I'm going to be down here on the negative sign, quadrant 3 and 4. Okay. I'm going to go 2 to the right, 2 to the left of the starting point. H and K is 0, 0. Let me go ahead and put my H and K for now. There it is. Let me go 2 to the right, right here, 2 to the left, right here. When I add 2 plus 2, it gives me 4. So 1, 2, 3, 4, right here. That's it. We make our cardio nice, as neatly as possible. Cardioid. Here we go. All right. And then we answer the question. How many x-intercepts do I have? I have 3 x-intercepts. I only have 2 y-intercepts. 0, 0, which is my starting point. And I have over here 0, -4 is my y-intercept. My x-intercept, let's start from left to right. We have -2, 0. We have 0, 0. And we have 2, 0. Those are our x-intercepts and our y-intercept. Now, of course, I don't expect you to have a nice polar graph grid like this. You can do freehand, okay? 1, 2, -2, 0, 0, 1, 2, 3, -4 is down here. There is your, no need for a, oops, I missed it. No need for a polar graph grid, okay? Everything should be labeled nicely. All right. Let's go ahead and do a limison. There is a little wiggly thing over here, symbol, that makes it the C sound be like an S sound. The limison graph, okay? So the difference about the cardioid and the limmason is that the limmason has an extra loop inside of it. Okay, we still do a cardioid, but then there's an extra loop inside of it. Very simple. I'll show you how this extra loop comes about. So if I have a positive sign, I'm going to be in the positive sign, which is up here. Okay, the sign is positive up here. Cool. I still start at H and K 0, 0. I still do like a cardioid, the value of A, I go to the right because I want to start doing my cardioid. I still add A plus the absolute value of B to make my longer length. Okay, we call it the outer loop. Outer, is there two T's? I don't know. Outer loop, maybe there's 2 T's. Okay, the outer loop. So I go A plus B for the outer loop, come back, the distance of the length of A here, and the inner loop is it's B minus A. Okay, so it's you add to go far, and you subtract B minus A to go the inner loop. Okay, that's the same pattern for a negative sign, and is the same pattern for a cosine. So we do the value of A to the left and to the right, A plus B to make the outer loop, and B minus A to do the inner loop. The B value will be bigger than the A value, okay? The A value will always be smaller, okay? A is smaller than the B value. So when you do the subtraction of B minus A right here, you're always going to get a positive value, okay? All right, let's go ahead and do I still have an example. Let me just do a one with, there we go. All right, notice that the B value is bigger than the A value. Okay, so the A value is less than the absolute value of B. So I know it's a cardioid. I know that my A value is 2. I know that my B value, the absolute value of B is 3. I also know that I have a positive cosine. I need to know that. Okay, positive cosine. So I'm going to be over here, let me highlight it, on the positive cosine pole. Okay, let me go ahead and start putting the points. We're going to go up 2, so up A, we start as center 0, 0, down A. I'm going to go 2 plus 3, that's we add, just like a cardioid, to go to the outer loop. So the 5 will be right here, 5. So there's my cardioid, go up, go to 5, and back. Okay, if I was doing a cardioid, but this is not a cardioid because the numbers are different. So I subtract 3 minus 2 to make my inner loop. So I went up, add together, 3 plus 2 makes 5, come back, and 3 minus 2 makes 1, so there is my inner loop. Okay, so you subtract, A plus the absolute value of B for the outer loop, and absolute value of B minus A for the inner loop. Okay? All right, now how many intercepts do we have? For the x-intercepts, I have 3. 1, 2, 3. For the y-intercept, I also have 3. 1, 2, 3, because the origin is on both axes. Okay, so let's start from left to right. We have a 0, 0 for the x-intercept, a 1, 0, and a 5, 0. For the y-intercepts, doesn't matter, let's start from the bottom up, just like range is always from the bottom up. Let's go 0, negative 2, 0, 0, and 0, positive 2. So from domain is always from left to right, range is always from bottom up, so we keep the same pattern. Okay? All right, let's do one more. This video will be short because it's very repetitive, but let's do one more. Okay, I'm going to do the next one without the grid, just so you see that you don't have to have this grid, you don't have to have all this fancy graph over here. Okay? All right. Here we go. The value of A is 1. The absolute value of B is a 3. I have a negative sign function. I need to know that. And let's go ahead and draw it. That's pretty much it. Okay. Without a grid, I actually prefer it without it. It looks nicer, cleaner. Okay, so I'm down here on the negative sign. I'm going to go 1 to the right, -1 to the left. I'm starting at h and k 0, 0. Add them together, 1 plus the absolute value of -3. 1 plus 3 is 4. So down 1, 2, 3, -4. That would be my cardioid. That's my outer loop. And then 1 plus the absolute value. Sorry, I'm lying. Liar. Here we go. Absolute value of -3 minus a 1, which is 3 minus a 1, which is 2 for my inner, the inner loop. So I'm down here at -2 for my inner loop. So let me go ahead and put it all these points, inner loop, outer loop. There we go. You're going to go up, outer loop, close the cardioid, and make your inner loop. Okay? All right. So we have 3 x-intercepts, 3 y-intercepts. Left to right, I have a -1, 0, a 0, 0, and a 1, 0. The y-intercepts from the bottom up, we have 0, -4. Then I have 0, -2, and then I have 0, 0. Okay? There we go. That's a negative sign function. It's down here on the negative, where the negative signs are. Negative signs are down here. Okay? All right, I hope that makes sense. I don't have any more examples. We can practice a lot more in class. Okay? And we're going to practice a mixture of them. 17 minutes for this video. Thank you guys. You're the best.